Hey everyone, I'm going to do a quick video on finding max, min, and concavity in Excel. This problem is from our 1.8 Excel example file. We started looking at this in class. So we have a function f of x equals 5 times x minus 2 times x minus 4 times x minus 7. We have our input table here. So here are my input x values. And then I've got my formula here. I always start equals 5 times. I have to put the asterisk sign. A2, that's my x value, minus 2, times my x value, A2, minus 4, times A2 minus 7. So that's all in there. So I also have the function graphed here, so I can visually see, as I read left to right, that my function is increasing up till I get to about that point. Then it looks like I'm going downhill or decreasing. I get to the bottom of that hill. That looks like my minimum, and then I go uphill. Now, I want you to also recognize that this is a polynomial. So even though I started my inputs at -1, the domain of this function is actually negative infinity to positive infinity. Okay, so I can use my table here. Remember, the definition of increasing is as x increases, what's happening to y. Okay, so here I go from -1 to 0. I increased x by 1, and my y value, or my f of x value, went from -600 to -280. So it increased, right? I would have to add 320, 320 to get to 280. Then I increase x by 1 again. I go from x equals 0 to x equals plus 1. And what happens to my y value? I go from -280 to -90. It's increasing. As x increased, what happened to y? It increased. When I go from x equals 1 to x equals 2, what happens to my y value, or my f of x value? It went from -90 to 0. So that is increasing. When I go from x equals 2 to x equals 3, my y values, or my f of x, goes from 0 to 20, so it's increasing. When my x value goes from 3 to 4, my y value went from 20 to 0. Now it's starting to decrease. When my x value goes from 4 to 5, my y value goes from 0 to -30. It's decreasing. When my x value goes from 5 to 6, my y value went from -30 to -40. It's decreasing. When my x value goes from 6 to 7, I go from -40 to 0. Now it's increasing, right? I had to add 40 to get to 0. And then lastly, when my x value is 7 to 8, my y value, or my f of x value, or my function value, goes from 0 to 120. It's increasing. So I can use this table of outputs to say, as x increases, what happened to y? Did it increase or decrease? And then if I look at my graph over here, I see that when x equals -1, y equals -600 down here. I can trace this. When x equals 0, my y equals -280. That's the point here. When x equals 1, my y value, or f of x, equals -90. And all the way up, I'm going up, up, up until I get to, I don't know, somewhere about here, right? And I can see in my table somewhere between x equals 3 and x equals 4, I decrease. So this maybe is actually closer to 3. Somewhere here maybe. So I want to find the exact value of x that will give me a maximum. And the way that I do that is I use solver. So I'm going to look in my table and I want to see where the maximum value is in the table, right here, 20. And to find the exact value, I'm going to do data, solver, and we can see here on solver, I can say I'm interested in cell B6 and I want to force it to find the maximum. So we can use solver to find maximums, minimums, or a particular value. In this case, I want solver to solve for the maximum value. Where do I want to put the result? I want to put it right next to it in A6. I always need to unclick that box. If I didn't unclick it and my x value was negative, if I didn't unclick it, it would not give me the correct answer. And then I click solve. Okay. So I can see here that when I have an x value of 2.88, my maximum value is 20.3033, okay? And so that is pretty close to 3, but if I want to write where the actual x value is, I have to use solver. We'll fill this in later. So now, let's go back. Let's find the local minimum. I'm going to go back to my table and I want to see, remember the definition of a local minimum is where my function changes from decreasing to increasing. So here I'm changing from decreasing to increasing. So I want to find my local minimum. I want to find the smallest value in the table, that's negative 40. And I want to find the actual minimum value. This might be pretty close to it, but we use solver to find the exact or pretty close to the exact. So I always want to remove that information that was my prior objective. Instead of finding a maximum now, I want to find the minimum value. Where do I want to put the result? I want to put it right next to my B9 cell. And I'm going to solve. So now here, I have found my actual minimum. So when x equals 5.7863, my f of x or my y value is equal to negative 41. That's how I get the exact value. So if I come over here, I can see when x equals 5.667, somewhere right here, my y value is negative 41.044. Okay. So I use solver, my local max is a value of 20.3033 when x equals 2.8803. Or I could say my local max happens at the point 2.8803, comma 20.3033, and I have a local minimum of negative 41.044 when x equals 5.7863. Okay, I could write that as an ordered pair as well. All right, so let's find where the function is increasing. So here, right, I know that it's increasing all the way up until my maximum. Okay, so I found where my actual maximum was is an x value of 2.88. If I want to write the interval, I'm from negative infinity, because this is a polynomial, this function keeps traveling downward. Okay, so my x's can get smaller and smaller up to the maximum point. To the top of the hill, my x value is 2.880367. Now my function goes up to that point and then it's decreasing, but from this minimum all the way up here it's increasing as well. See over here in my table, from the minimum now it starts to increase again. So I have to connect both those pieces with a union sign. It's increasing also from negative 41.044 all the way up to positive infinity. Where's my function decreasing? It's decreasing between the maximum all the way down to the minimum. So I write that interval as 2.880367 all the way up to, oops, sorry, I made a mistake here. All right, we were putting the x values in. 5.7863. We always put the x values in our intervals. Sorry about that. Okay, all the way up to this one here. 5.7863. And so now if I'm going to estimate where it's concave down, well, I need to look at my average rate of change. So I'm going to do an average rate of change calculation. Concavity happens when I change from concave up to concave down, is at my inflection point. So here, if I do average rate of change, this is equal to that minus that divided by my x values, x2 minus x1. If I copy that down, I'm looking at how is my function changing. So between x